Hey, everybody. Thank you for sticking it out, staying for the final session of the evening. I think it's funny, conferences are kind of like the opposite of concerts. You have the keynote first, and then the worst acts are last. But I like to think I'm closing out this day, so yeah, I'm the headliner. Do I need to do something to get the screen going? All right, we have a lot to go through today. We have a couple of pretty exciting demos and everything, so let me get started quickly. This presentation is called Full Stack Kotlin and Google Cloud. My name is Brent Shaffer, and that got messed up, but my Twitter and GitHub handle is bshaffer, so please contact me if you guys need anything or have any questions. A little bit about me. So if you do a quick Google search, you'll find I'm not really big in the Java or Kotlin community. It's because I'm actually mostly a PHP dev. Sorry. But so in the past couple months, Google has wanted to invest in, specifically Google Cloud has wanted to invest in Kotlin resources, and so they looked to me to get started. And I was pretty excited because I love the PHP community. I've been doing it for about 10 years, and Kotlin's a very exciting space. So I'm very new, but so far it's been an awesome experience. So I overheard this at Google once, and it stuck with me. I thought it was hilarious. No language makes you feel more like a cog in a machine than Java, and this is because there's very specific way to do things in Java, and it doesn't leave a lot of room for creativity. Sorry if this rubs you guys the wrong way. This is kind of my feeling of Java, but when I started with Kotlin, I kind of felt that all of that went away, right? And I imagine you guys all feel the same, and that's why you're here. So, hooray. It really seems like a huge win. So, like I said, I was tasked with creating Google Cloud resources for Kotlin developers. And so we really identified two major camps for what that meant. The first one was Java backend devs that were very familiar with building backend applications and rich web applications that I wanted to switch to Kotlin for kind of the reasons that I mentioned on a previous slide. And the second camp, obviously, is Kotlin developers that are more familiar with the Android platform, and they're wanting to use a language that they're familiar with and libraries they're familiar with to build server-side apps. And there's a third camp that's kind of related, which is Android things developers and IoT developers that are also using Kotlin. So humor me for a second, because I've basically been guessing how many people in this room have built rich web applications in Kotlin or APIs? Okay. Oh, okay. That's good. Only two people raised their hand up first. I'm like, oh, crap. How many of you are Kotlin Android devs or have built Android applications in Kotlin? Okay, that's a large percentage. And has anyone built Android things apps or IoT apps? Okay, we have quite a few of you, like 10. Okay, so for those watching at home, it was about 20%, 75%, and then 10%. So that's actually pretty close to what we thought. That's awesome. So Java devs, this was really easy because we have a very rich Java ecosystem on the Google Cloud. It's been, if there's two languages that we support more than any other languages, Java is one of them, right? So a lot of the infrastructure is there, the ecosystem is there, client libraries are there, that kind of thing. So, but we wanted to start out by supporting some of the major frameworks that are really popular in Java. So we have tutorials on Spring Boot and Spark, and also Ktor, which is a more idiomatic to Kotlin framework. One thing that we are working on, and I want to preface this by saying, if you saw the keynote today, one of the things that was announced was cloud.google.com/Kotlin. It was very small on one slide, and I got really excited because this has been my project. And today is the world premiere of that page. So this is day 0 for Kotlin support on Google Cloud. But one of the things we're going to do in the near future is build Kotlin-specific client libraries. So at the top, you have what the Java client libraries look like if you just write them in Kotlin. And they still look really good, and they look better than in Java. But you can see we're using builder patterns, things that aren't really necessary in Kotlin. So the second is an example of what we have already built, actually, and we're just in the process. It's on GitHub right now, but we haven't even gotten to an alpha release of it yet. So stay tuned. We're going to get to Kotlin DSLs for our client libraries so that there's much more idiomatic and fun ways to call our APIs. So for Android devs, this to me is a super exciting world, right? Having Kotlin running on the back end opens up a ton of opportunities and possibilities. So now you can have shared libraries on the front and back end. You can have really easy migration if you want to move any of your logic from one to the other. If you want to have a lighter weight Android app, then you can quickly move stuff into the back, and we want to have resources for you guys to do this. Another thing is we want to have frameworks that we can recommend, and the ways of doing things that we can recommend if you want to create a quick function and call that from your Android app and stuff like that. So, just one more plug for this. Go check it out. This is the page that we launched. We're basically trying to make it a Kotlin portal, collect all the resources, the best resources that we have for all sorts of stuff that you can do in Kotlin. Okay, so enough of that plug. Now I'm going to actually get to the business. So today we're talking about not quarter stack or half stack, but full stack development, baby. So we have not one, but two demos. The first one, we're going to extend an Android app with an auto-scaling backend. And this is going to be, well, OK, I'll just say that for now. And then the second demo is remotely configuring Android things with IoT Core. So the first one we have available as a code lab. You can walk through this on your own. Please check it out. It's very cool. So what we're going to do is, first off, if you want to build a backend for your mobile app in Kotlin, we have a couple of options, and these are just the most popular ones. And if you're not familiar with our products, I'll go over it real quickly. We have Compute Engine, which is our virtual machines product, and this is obviously pretty straightforward if you want to deploy this to Kotlin to this. And we also have a really nice UI and great tools you can use to provision more VMs and stuff like that. If you want something that's a little bit more it's a platform as a service, so I guess less hands-on. Try App Engine, and that's what I'm going to be showing off today. And then if you have a more complex application running microservices and you haven't heard of Kubernetes, please check it out. I wish I had time to talk about Kubernetes because it's one of my favorite products that we have, but I don't. There's a lot of other talks on Kubernetes, so check it out. But it's a really, really cool product. So I chose to use Spring Boot, and I know that frameworks are a little bit of a religious topic. So how many people here like Spring Boot? Let's see. Okay, it's about half. Sorry. Yes, like it. I meant like. We had about half of people say they like Spring Boot, so that's great. So I chose it because I thought, one, it was popular. Two, I like the convention over configuration, so I didn't have to write too many configuration files. It has Kotlin support already, and you should check out start.spring.io if you haven't. It launches a Spring Boot application for you, so you can download it. You can add GCP support, and then it will automatically add that to your POM or Gradle file. So it's really handy to get started. So it works great with App Engine. And then we chose App Engine because if you're not familiar with App Engine, it is one of the first, if not the first, serverless offerings ever. So who can tell me when it launched? Anybody?
2008.
Yeah, wow, this guy. Okay. Yes, 2008, so it is over 10 years old. That's probably older than some people who are writing Kotlin. So the idea is the developer provides the code, and Google runs it on our infrastructure, and we can run it at the scale of 0 to what we say infinite. And I don't know how we can say that because you guys know as much as anyone or more than anyone else that you can't say infinite. Nothing's infinite. But I guess what we mean by that is you guys, that we don't think anybody can scale past what we can provide. And we run Snapchat on App Engine, so I think that's a pretty true statement. Yes, and so you can go up to millions of queries per second, and we support 7 languages. It's pay per use, and it consumes resources when your code is running, which makes it great for prototyping like we're doing today, because so you get 28 instance hours, and that's for free. And there's only 24 hours in a day, so if you do the math, that means you can have it running all day, and then you can even go up to 2 instances in case you get a little bump in traffic, and it's still free. So this is what it looks like. This is actually even more complex than you need it to be, because I've added the automatic scaling section there, but by default it's just from 0 to infinity. You can add some parameters on how you want your instances to scale, and that properties file is also optional. Really, all you need to do is specify runtime 8. I should mention that if you've used App Engine a year ago or earlier for Java, this is a whole new ballgame. We launched Java 8 last year, and it's so much better than the previous versions. The previous versions, not just of Java, but of all our App Engine runtimes, had a very restricted sandbox to prevent security issues and to help us scale the instances up so quickly. And it was really impressive that we can scale them up, but the pain and headache in implementing anything on App Engine was not really worth it. So I encourage you to give it another shot if you haven't yet. The new runtimes are amazing. We use a technology called gvisor. This is on GitHub, and we announced it at Cloud Next, if any of you were watching that. And it's incredibly impressive technology that lets us implement these runtimes super quickly without having to restrict your guys' code. So let's talk about the app. This is an amazing app coming to an app store near you. It's gonna be big, gonna go public soon. It's called Emojify, and what we're gonna do is allow the app on the phone to take an image or upload an image. We're going to detect any faces that exist in the image and put an emoji corresponding to the detected emotions onto the image and return it to the phone. So these are the emotions that we're able to detect: happiness, surprise, anger, sadness, and whatever that is. And so these are the client libraries / APIs we're going to be using. One is Cloud Vision for the face detection in the image annotation, and the second is Cloud Storage, which is our CDN type service where we can store images and then pass them between the front end and the back end. So I have a little flow chart here just to make it clear. We have Firebase SDK for uploading the images to Cloud Storage, and then once we have an image URL, we're going to call the backend with it. The backend is then going to call the Vision API and then do the logic to overlay the image, stuff the new image in Cloud Storage, and then return an API response to the front-end application with the new image location in the form of a JSON response, right? So let's do it, guys. All right. Wow. That is awesome timing. Okay, so I'm going to take, oh wait, there's people with orange badges. I don't know. I was going to take a selfie and see if I could get everybody in it, but I don't know. People with orange badges are here, so. Maybe I could just get a corner where no one's orange badging it. I really want to do this. Can I say if you don't want your picture taken, can you go to this side of the room or something? Is that okay? I don't know what to do. All right. We'll do that. Thank you, guys. Sorry to make that awkward. Okay, 3, 2, 1. Do an emotion. All right. So it already uploaded to Cloud Storage. That was the crossing fingers. Now something is coming. This means it's waiting on the API. Okay, sweet. Let's see. We got a couple of people in the front there. That's awesome. And all smiles. Nice work, everybody. So let me just show you what that looks like for deployment. So this is, here I have the code downloaded locally, and of course you can use IntelliJ if you're interested in using that. And when you press run, there's a App Engine plugin that will automatically deploy it and roll it out to production, which is pretty cool. But for this demo, I'm just going to go ahead and run Maven App Engine deploy and time it so we can see how long it takes. And this code here is available. We have a GitHub repository, Kotlin samples, and all of the code that I'm showing today is in this repository and more if you're interested in that. So right now it's building the project, and then once it's done building, it'll deploy it. Most of the time is actually spent building the project. When it deploys, it's incredibly fast. It's under a minute. So we'll see how well this goes. And then once it's available, App Engine automatically deploys your application on an appspot.com URL, again, so you can really be fast at prototyping and getting started. And you can obviously add a custom domain whenever you're ready for it. So here we go. Now we're doing the actual G-Cloud deployment part. And this is deploying to KotlinConf 2018, because that is the name of them. That's my project ID. So it looks like that's going to be done pretty soon. I'm going to go to the URL. Emojify is the name, and then I have this query string parameter that tells it what the object name is, so we can find it in cloud storage and make it the request. Let's see, okay. So that deployed in 1 minute and 26 seconds. That's not bad at all. And so this is what it looks like. You make a request of our backend or API, and it will send you an emojified URL, and this will download your emojified image. So that's pretty cool. There's obviously things like if the path is wrong. Wow. Yeah. So there you go. So that's basically the gist of the demo. And let's talk a little bit about where do I go to? Oh, here it is. About the code itself. So on the Android side of things, we're using the Firebase SDK to upload the image. And once it's uploaded successfully, we have this call emojified backend function, which then does a very basic RESTful request to our backend URL. On the backend, if you haven't used Spring, this is what it looks like if you want to annotate a controller. So we have our controller at /emojify, and we specify a request parameter called object name, and then we go on and handle the request from there. And this is, pretty much the entirety of this entire demo is just this one function, which is pretty nice. So here, this looks familiar. This is the same example I used for the Java library slide. So this is the Java client libraries being used to call the image API, the vision API. And then once we have that, we iterate over the annotations from the response and draw the emojis onto the image. And then we go ahead and write that back to a cloud storage bucket. So just to reiterate what we covered: Firebase SDK, cloud storage, Cloud Vision, and App Engine. All right. So let's go to our second demo, remotely configuring Android things with IoT Core. And this is also available and also on the GitHub. So please check it out. And this one is pretty fun. So IoT Core. So IoT is kind of a buzzy word. And just so we're all on the same page, I'm going to define it super quickly. So a computer is considered IoT. Your phones are definitely considered IoT. And smart devices like a Google Home is considered IoT. And these are always-on devices, what we call them. And then edge devices are periphery devices that are either communicating with another device like Google Home in order to get to the outside world, or sensors, like very small devices that are connected to a network at all. These are also IoT devices. And those devices are, they could be just very, very, very small, running a single program, that sort of thing. So because of this, we're having a huge growth in devices that are connected to the network. And in 2020, we're supposed to have 20 billion. So humans, where humans on the list, they're a little bit below the 10 line. We're at 8 point something, 8.4. So bad news, we're already surpassed. There's more devices than us. There was $250 billion spent on IoT services last year. So, and that's just services. That's not hardware. That's not installation. So, this is a huge area for to make some money. And so that's why I'm giving this presentation. We're investing heavily in it, and we think you guys should too. So moving on, Cloud IoT Core is the product that I'm going to demo real quickly. And there's a lot of detailed information on here, but this is going to be a pretty high-level overview. But basically, you have a device that will communicate with our servers using either MQTT, which is a very fast and lightweight protocol. So like I said, you have a very small device with a very tiny processor. It's not very capable of doing complex things. You might not want it to use HTTP, because HTTP is actually a pretty heavy protocol. So you can use MQTT. I did want to say I did some research, and it's interesting. Java runtime can run in 40K if it's heavily optimized. So that means you could have a device with as little as 40K, well, maybe a little bit more than that. But you know what I'm saying, that small of a device could be capable potentially of running Java runtime and making these calls. So yeah. All right, and then the second component of IoT is the device manager, and this is basically just a way for you to organize your devices, because theoretically you could have lots, you could have hundreds, you could have thousands. And again, cell phones count as this. So I can definitely think of some use cases where you would want to manage your Android app with IoT Core, because we have some products like Firebase that you can use for sharing state across devices, but if you're talking about the scale of millions of devices, Firebase is not going to be a good solution, whereas IoT Core, the main thing about this product and why we really like it is because it is incredibly scalable. A million devices would not even phase it, right? Because we're looking at a much larger scale for some customers that have maybe 100 sensors in 1,000 different factories or something like that. So yeah, again, it's really simple. You basically just have your devices. You can do a registry. You can have one or more registries, all in IoT Core. And so if you're not familiar with Cloud PubSub, it's another product we have that's a messaging bus. So whenever any of these registries get information about these devices, they publish that information to Cloud PubSub, and then one of a number of processes can listen in on Cloud PubSub, subscribe to that data, and then do whatever based on that subscription. So here's a little animated model of what's happening. You have a device that is constantly sending information to Cloud IoT. And this can be telemetry data, typically, so sensor data or just information about itself in general, like crash reports or whatever else. And then IoT is going to publish all of that data to Cloud PubSub to allow you to customize what takes place after that. So some of the things you can do, you can build a cloud function that's integrated really easily in Google Cloud Platform, so that you can write functions that ingest that data quickly. Data flow is another product, or you can listen to it on anything. You can listen to it on it with client libraries that you can run locally. So if you want to take it a step farther, you can stick this data into Bigtable. You can stick it into BigQuery to run some analysis on it. You can do machine learning on it. We're talking about huge data sets, so this is a really good opportunity for machine learning. And then eventually, if you want to, you can build some dashboards and do some cool stuff. So I know this is a little bit markety. I made this slide. I'm not a markety guy. I thought this was a cool way to visualize it, which is you have your data being ingested by IoT Core. Then you can process it through PubSub, Cloud Functions, and some other, whatever subscribes to PubSub. And then you have some other products that can analyze it. OK, so that was boring. Let's talk about the app. We are going to build an awesome coffee warmer upper. And these mugs are available in the Google Cloud gift shop. Just kidding. Maybe next year. So what we have is a Raspberry Pi, and a Raspberry Pi is going to control this device. And we have a rainbow hat, which will show us what the temperature is of the device. It's basically the temperature sensor and the temperature indicator. So unfortunately, this is too low budget of a presentation for me to actually have these things. So really, we're going to just imagine that that's what this is doing, and the temperature itself and the heater is going to be simulated by the rainbow hat. So the third component that we have is a Kotlin server, which is going to be listening to Cloud PubSub and based on the temperature that is being reported by the Android Things device, it's going to either turn the heater on or turn the heater off by updating that device's configuration. Okay, cool. So here's a flow chart just to drive the point home. The Android Things device is going to report its temperature as telemetry data to the IoT Core server. IoT Core server is then going to publish that data to Cloud Pub Sub. We're going to have a constantly running Kotlin server in a main loop that is going to be listening to Cloud Pub Sub, pulling down new topics and watching for whenever the temperature either is above or below a certain amount, a certain threshold, and depending on that threshold, it will issue a configuration change to the IoT Core, which will then update the device, and the device will update itself as a result. Okay, so let's go to the demo. Sweet, here we are. I have to unplug my selfie phone and plug in the rainbow hat. Sweet. And again, this code is available online, so you can run it yourself. You can also simulate the rainbow hat controller, so you don't need to have that, even though it's pretty cool. All right, so let me see if this runs. I've never gotten this to run on the first time, so we'll see what happens. Usually, this guy should light up if it's being built correctly. Is it even running? Okay. Here's an error. That's good. Yeah. Is this taking a lot longer than it should? Wow. Okay. Let me try to run it again. See what happens here. There we go. Okay, so you can see here it's flashing, and then if it can connect to the internet, which is usually the part where I get stuck. Oh my gosh, I didn't turn my hotspot on. Okay, so I'm going to turn my hotspot on because I don't trust the conference Wi-Fi, and then I'll have to restart this once this works in order to get this demo to work. And I have 17 minutes. This is going to be perfect. Okay, so because that flashing is annoying, I'm going to go ahead and stop this. And because I need to stall for time, I'll show you guys the actual code here. So this is coffeecontrolactivity.kt. This is the Android Things controller that we have running. And, you know, don't judge my Kotlin development. I'm going to clean this up, I promise. But so we have this function here is what publishes the telemetry data to the to IoT Core. You can see we're going to be reporting our data every 2 seconds, and we're using this client object to do it by instantiating a JSON payload. And then, so in the actual creation, here's where we create the client, and whenever we create our IoT Core client, we specify a onConfiguration received function. So this means what our Android Things device is going to do whenever IoT updates its configuration. And if we go down a little bit further, where did oh, shoot. I'm so sorry, guys. Is it? Wow, that's really annoying for you. I think it's a faulty cable, because I'm for sure. Well, I'm not going to blame it on the cable. Has it really? Oh my gosh! So my entire presentation's ruined. That's great. Okay. Well, wow, that's really frustrating, guys. Oh yeah? Okay. Well, that I can do. It's a perfect ploy to stall while my hotspot continues to start. All right, so will it work if I go to 720p? That is wonderful. Okay. Yeah, so far so good. This is great. Thank you for bringing that to my attention. I'm sorry that's been going on the whole time. Glad none of you guys are, have epilepsy. So my hotspot is still turning on. I'm really sorry. This is, I was going to start that and I forgot. So let's see. While that's still going, I'll continue to just go through this code. So when we create, oh gosh, it's still doing it. So this onConfiguration received function, whenever we get this, we JSON, we decode the new configuration, and then we just set the configuration on our on a property so that we can update our behavior. And that is the client. Let me go to the server now. Let's see. Here we go. Here's our server. So, you know, and again, one of the advantages of using Kotlin full stack is that we can use the same libraries, front end and back end, for consistency and max efficiency. So this is the Kotlin library for JSON parsing. If you guys have used it, it seems pretty popular. And here on the server, we're listening to pub/sub, and when a new message comes in, we execute this command where we go through and parse the data. And if the data matches what we expect, we go ahead and check the temperature. If it's less than 0, then we turn the heater on, and if it's greater than 0, then we turn the heater, or 10, then we turn the heater off. Man, my hotspot is still starting. This is frustrating. You know what I could do is try to connect to the conference Wi-Fi, since I have nothing else to do. Okay. I have a feeling this is going to not go well. Okay. And then who can tell me what the okay. It's worth a shot. KotlinConf. Does that look right? Stop me? Nope. Okay, sweet. All right. Let's see how good this Wi-Fi is. So if it connects as expected, it will start counting up. If it keeps flashing, then it's not so good. Okay. Let's see what we have here on a logcat. Okay. Yeah, it looks like we're still having trouble connecting. So let me just see if anything's getting through. So there's a command. gcloud is our command line utility that we can use to, you can listen in on pub/sub topics or subscriptions. And I created one called telemetry server. Pull. So we'll see if any of these commands got through, so I can show you what one of those looks like. And yeah, okay, so some of them are getting through. Temperature 0. And you can see this is kind of the data that IoT Core automatically sticks into these messages. And this is the custom message that we stuck in, the data part. Let me just auto. So I'll acknowledge these so that they won't be there whenever we actually start our server. Let's see, so I have about 5 minutes to fix this. That's not good. Okay, I'm going to stop this. And I don't know why I turned my hotspot off. I was trying to save batteries, which was obviously a mistake. Yeah, I mean, why not, I guess. Is it currently running? Sweet, yeah, let's do it. Oh, hey, conference Wi-Fi is working actually, so we'll stick with this. Okay. Thank you, man. All right, so here's the rainbow hat. Now, what you can see is happening is the by default, it heats up. So it started up, it detected that it was, the temperature was 0 on our coffee, and so now it's warming up the device, and the red there is displaying that the heater is on. So if I come back to the command line here, I'm going to run our server, which again, it just listens to the pub sub messages and updates the device configuration. And you can see here, it's already receiving these messages. Temperature of 2. This 99 is from the past device when it was flashing. So let's see. I'll just restart it so that we're not. Yep, these are the up-to-date ones. Okay, awesome. So you can see here, now it's blue because it turned the heater off. If we go to the output of our server, it says the device has a temperature of 14, setting heater state for the device Rainbow Hat 1 to off. And if we go to our Android logs, we should see, that's interesting. I'm not sure why. But yeah, this usually outputs that its configuration was updated. So going back to our coffee heater here, once it hits 0, we should have another device configuration change command updated to turn the heater back on, and then we'll see it switch to red. The suspense is killing me. Here it comes. Yeah! Cool. I'm going to clap for myself. Thank you. Awesome. Thank you guys for being patient with me on that one. So, just to wrap up real quickly, I wanted to pitch, well, I already kind of showed you guys this stuff while I was stalling, but real quickly, this is the device code to initiate the IoT Core client, where we specify the function on our device to execute whenever a configuration change is received. Then we have the publishing of the telemetry event, where we can stick any kind of arbitrary data we want. Doesn't even have to be JSON, but you know, that's what we're using because that makes the most sense to me. And we publish it every 2 seconds, but again, your devices could publish this hourly, daily, monthly, it doesn't matter. But PubSub can handle each second. These products scale incredibly well. So this is what our server is doing. It's listening to the PubSub topic, and whenever a new message comes through, it parses the data into JSON, and then depending on the temperature, it will modify the device config by issuing a request to the IoT, Cloud IoT. And then once this happens, the device is notified, and it pulls down the new configuration. So that's pretty much it. I know I said that like probably more times than I needed to because it's very simple. But so Cloud IoT has been out for a little bit over a year. One cool thing that I wanted to mention is IoT Edge, which is like, so you know, the fact that you have a lot of devices reporting on a ton of data that's going up into the cloud says that you could do some really potentially cool things here with machine learning. So IoT Edge is something we just announced. It's an alpha, and we've created little devices that are very similar to, they look very similar to a Raspberry Pi, but instead of a normal processor, they have a TPU, which is a tensor processing unit, and that is optimized for running machine learning models. So the idea is that you send in all this data from your devices, you train machine learning models in Google Cloud, and then once you have new models based on better data, you can update your devices that are on the edge, all from the cloud without having to touch any of them with new machine learning models so that they can, whatever they do it better. So that's a pretty cool thing. And let's see, I think that's my final slide. So I can't even get back to my slides, so we'll just call it at that. Yeah. I have, the only thing we're missing is a slide that says any questions. So any questions? Yes?
Currently the Google
yeah, please use the mic.
Hello, hello. So currently I was Googling a bit about the boards that you can use to do something with the Google IoT. Is there any plans to release more boards, smaller? Because I think I just saw one with the prototyping.
I don't think I can talk about any of that stuff,
Okay.
but I can say that, yeah, like, you know, we've released Android Things boards in the past. We plan to keep doing that, I imagine.
Okay.
So. Yes, up here in the front.
Do you have any plans to support Kotlin for Cloud Functions as well?
Oh, you guys are asking all the questions I can't talk about. I can tell you that I don't know what I can tell you. I will not deny that it's going to happen. But I will say that I think personally that it would be amazing to have it, and that I will work very hard to try to make that happen. Because yeah, it's a perfect fit. It's a perfect fit, especially for this exact thing. I would love to be doing this demo with Cloud Functions instead of App Engine, because it would be an even better fit for one-off functions. If you're not familiar with Cloud Functions, it's essentially what I showed, except instead of having to do /emojify and use Spring Boot and have any of that, you would just have the function that makes these API calls and ingests the query string parameter, and it would simplify things significantly. So yeah. Any other questions?
Yeah, so in your app engine, you currently trigger when something happens when you upload an image to your bucket, right?
Well, it's not really a trigger, it's just a HTTP call.
So
the
you get an HTTP call when something's uploaded to the bucket, or the client informs your app engine?
Yeah,
that
it could be smarter. You could have the Android app listening to changes on the cloud storage object, and if it's modified, then it pulls down the new one. What it does instead is it just waits for the JSON response from App Engine, and then it uses the returned bucket name to display the image.
Okay, so maybe I missed it, but you upload the image to the bucket, and then you call App Engine to do stuff with the image. Okay.
Exactly. Yeah, and you're right. It could definitely be more efficient, which is why it took a little bit of time. You could definitely speed that up. Any other questions? So yeah, you know, I would love your guys' feedback on this. I think that Kotlin in the cloud is a great fit. I think we can do some really, really cool stuff. So I'm hoping to, you know, be a part of that, and hope you guys will be too. So, you know, feel free to reach out to me and let me know how it goes. And that's it. Thank you, guys.